Question 11, probably the hardest question on the paper. This question is about compounds containing ethane diorite ions. So an ethane diorite ion is C2O4 and it's a 2- ion. We know it's a 2- ion. It shows you it here, C2O4 2- anyway here, and it's in this C2O4 and it's in this C2O4 as well. So we've got a white solid that's a mixture of sodium ethane dioate, which has got ethane diorite ions in it. You can see C2O4 here, and we've got a reaction involving ethane diorite ions in a minute here, C2O4. So ethane diorite ions are going to be formed from this sodium ethane dioate, and also from ethane dioic acid dihydrate, which is this, which has also got them in. So the first thing to note is that this white solid that's a mixture of sodium ethane dioate and ethane dioic acid dihydrate, which is this, and an inert solid, some other kind of impurity, has got two solids, two reactants, making ethane dioate. So the ethane dioate that we'll see in a minute has come from both sodium ethane dioate and this other thing, ethane dioic acid dihydrate. So what have we got first of all? Well, it's told us how much of this solid that is mixed into 250 centimetres cubed of aqueous solution. And we've got a couple of titrations going on. In the first titration, 25 centimetres cubed of the solution were added to an excess of sulfuric acid, and the flask and contents were heated to 660 degrees C and then titrated with 0.02 moles solution of potassium manganate 7, when 26.5 of potassium manganate 7 have been added, the solution changed colour. So immediately I'm thinking, we've got a concentration, we've got a volume of potassium manganate 7. We should work out the number of moles. So I've got concentration is moles divided by volume. Concentration is 0.02 equals moles divided by volume. I've put the volume 26.5 centimetre cubed. I've divided by 1,000 to get into decimetre cubed. So a small unit like centimetre cubed up into a larger unit like decimetre cubed, you divide by 1,000, 0.0265. The number of moles is 0.02 multiplied by 0.0265, 0.00053. So that's the number of moles of potassium manganate 7, which is this that I'm going to react with the ethane dioate. Why have they given me this equation? They've given me this equation because it tells me 2 moles of this react with 5 moles of this. Or if I halved it, 1 mole of this would react with 2.5 moles of this. So for every 1 mole of potassium manganate 7 that I've just worked out, 2.5 moles of the ethane dioate will react. So for every 2 moles of potassium manganate 7, 5 moles of ethane dioate react. 1 mole of potassium manganate reacts with 2.5, therefore, moles of ethane dioate. So if I've got 0.00053 moles of potassium manganate 7, it must react with 2.5 times that. So 0.00553 multiplied by 2.5. I've now worked out the number of moles of ethane dioate that I've got. So where does the ethane dioate come from? Well, I've said it comes from sodium ethane dioate and it comes from the ethane dioic acid dihydrate. It comes from both of these. So it comes from both the chemicals. So the sodium ethanoate and the ethane dioic acid together in the sample are that number of moles because they make the ethane dioate ions between them. So the number of moles of this added to the number of moles of this, they both contribute towards making the ethane dioate ions. So the number of moles of ethane dioate ions is 0.001325. We've established that. So the number of moles of these two chemicals, the sodium ethane dioate and the ethane dioic acid dihydrate, must add up to 0.001325 together. Okay, the second titration is with sodium hydroxide. So the second titration with sodium hydroxide, I've got 25 centimetres cubed of solution. So I've got a sample of the solution titrated with 0.1 moles solution of sodium hydroxide using phenolphthalein as an indicator. The indicator changed colour after the addition of 10.45 centimetres cubed of sodium hydroxide. So I've got a concentration, I've got a volume of sodium hydroxide. It wants me to work out moles. So Let's have a look. So it wants me to work out moles of sodium hydroxide. Concentration is moles divided by volume. Concentration is 0.1. I've been given that. Moles divided by the volume. Well, I've got 10.45 centimetre cubed. To get centimetre cubed up into decimetre cubed up into a larger unit value, I divide by 1,000, so that's 0.01045. Multiply the two together. 0.1 times 0.01045 is 0.001045. I know the number of moles of sodium hydroxide. Let's have a look at what the sodium hydroxide does. It reacts with this chemical, H2C2O4, which is just this one. This one hasn't got H2C2O4 in it. This one has. The ethane dioic acid dihydrate has got H2C2O4. And 2 moles of sodium hydroxide, the sodium hydroxide is making these OH minus ions, 2 moles of the sodium hydroxide react with 1 mole of this ethane dioic acid. So if I've worked out the number of moles of sodium hydroxide, if I half that, divide by 2, I will work out the number of moles of ethane dioic acid that it's reacting with. So I've now worked out, because the sodium hydroxide will only react with the ethane dioic acid part, then 0.005225, in other words, this value of my sodium hydroxide divided by 2 tells me the number of moles of ethane dioic acid dihydrate in there, which equals 0.005225 moles. So, I know the total number of moles of these two chemicals added together is 0.001325. I know the number of moles of ethane dioic acid dihydrate is just 0.005225. So if I subtract the two, I end up with a number 0.008025. This must be the number of moles of sodium ethane dioate on its own. So the moles of sodium ethane dioate in the original 250 centimetre cube sample, because remember these reactions have been taking 25 centimetre cube samples out, are 250 divided by 25, which is 10. I've got 10 times the amount in the original solution. So I need to multiply by 10. I've got 0.008025 moles of sodium ethane dioate in my original solution. Now, finally, we're nearly there now. Moles equals 0.008025. We've decided that. Moles is mass divided by MR. I can work out the MR of this. 2 23s, 2 12s, and 4 16s. That's 134. So my mass of sodium ethanoate, sodium ethane dioate rather, my mass of sodium ethane dioate equals 0.008025, that's the number of moles, multiplied by the MR 134 is 1.075 grams. So that's number of grams of sodium ethane dioate that I have in my sample. And finally it's asked me to work out the percentage by mass, so 1.075 grams out of a total mass of 1.9, because the original solid mixture contains ethane dioic acid dihydrate and another solid that we don't know what it is. So the percentage of sodium ethane dioate in there is 1.075 grams divided by the total mass of all of the solid together, multiplied by 100%, which is 56.58%. Ethane dioate ions, we know that the C2O4 2 minuses, so we know what they look like, and they look like that: CC, double bond O, O, O minus, and another O minus, and each of the O's have got a pair of electrons on them. That's what it looks like. It's probably worth remembering what an ethane dioate ion looks like. Write an equation for the reaction between iron 3 ions. So remember, iron 3 ions are going to be FeH2O6 3+. Now this is a bidentate ligand because it's got 2 lone pairs to donate into 2 covalent bonds. So it forms 2 covalent or coordinate bonds, where the covalent bond has been formed by the donation of a pair of electrons from one of the atoms only. So it's forming two coordinate bonds or dative bonds, same thing, two coordinate bonds or two dative bonds with the Fe central metal cation in the middle. So I only need 3 of these to make 6 coordinate bonds. So I need 3 of these to replace the 6 waters. So 3 of them. How do I know it's 3 minus? Well, this is Fe3 plus because waters are neutral, have no charge. They have a 0 overall oxidation state. Fe3 plus in a 3 oxidation state, 3 plus oxidation state, 0 leaves 3 plus overall. These are 2 minuses each, and I've got 3 of them. So 2 minus multiplied by 3 is 6 minus. 3 plus for the Fe, 6 minus for the 3 ethane diarrhea ions leaves 3 minus overall. 3 plus, 6 minus, 3 minus overall, and it balances. So I've got 3 plus and 6 minus gives 3 minus on the left hand side and 3 minus on the right hand side, and 6 water. Suggest why the value of the enthalpy change is close to 0. It's because the number and type of bonds that I'm breaking are very similar to the number and type of bonds that I'm making. So remember, in water it's a lone pair of on the oxygens of the water that bonds to the Fe in 6 coordinate bonds, and here I've got 6 coordinate bonds, albeit from 3 ligands now because they're bidentate ligands, again from the oxygen. So the same number and type of bond being broken here, broken as the waters are released, and then the same type of bonds being made, and in the same number with a coordination number of 6 coordinate bonds as 3 bidentate ligands that then bond. Draw the displayed formula of ion complex produced in the reaction. So what I've got is, I've got 3 of these around a central ion. I've actually just drawn it here as a tetrahedral, an octahedral structure, but you don't really need to do that. You can just draw it flat if you want. I've got an Fe, and I've got an ethane diarrhea ion here with a bond between the Fe and the O's. So the lone pairs of electrons on the O's are going to be forming coordinate bonds with the Fe, and I've got 3 of them around it, and I've got 3 minus charge overall because the Fe is in +3 oxidation state. Each of these are in -2 oxidation state because they're -2 ions. 6 minus around from the 3 ligands, 3 plus from the Fe leaves 3 minus overall. I'm not quite sure where the 3 minus is, so I'm just going to put a square bracket and a 3 minus around, show that I know overall it's got 3 minus charge. What kind of bond angle? Well, I've got 6 bonding pairs, no lone pairs, 6 bonding pairs, no lone pairs. It's going to be an octahedral shape with a bond angle of 90. Type of isomerism, well, if you've got 3 bidentate ligands around something, it's actually optical isomerism. So you actually get enantiomers, something just to remember. Ethane diarrhea ions are poisonous because they react with ions in the body. Ethane diarrhea ions are present in foods such as broccoli and spinach. It's just one reason why people who eat their foods do not suffer from poisoning. Then you're just not eating enough of them. They're in small quantities.